If there's a particle moving in a magnetic field, if it's a charged particle, then there will be exactly the same as a current in a wire. A positive particle moves in the same direction as the conventional current. So there'll be a force on this particle which will be in the same direction as there would be if you were doing the motor effect with a wire. So the field lines are going into the screen. So I need to point my fingers towards the screen, and then the current is going to the right because the positive particle is going to the right, so my thumb goes off to the right, and so the force on that particle has got to be upwards, the direction of the palm of my hand from the right hand slap rule. This is the same particle and the same field, but it's been pushed by the force, it's changed direction. So my fingers still line up going into the screen, but what you can see is that as the particles move around, my whole hand is twisted, so now the slapping force is in this direction, so it's changed from going vertically upwards to going at a slight angle away from the vertical. And as the particle moves around, as it changes its direction more and more, what we'll have is that force will keep being at right angles, because the slap is always at the right angles to the direction of the current. When you're dealing with a negative particle, you've got to remember that the current is in the opposite direction, so the current is this way. The motion of the particles that way, so a positive particle would be moving that way. So the field, I put my fingers pointing along the field lines again, but this time the current is this way in the direction of my thumb, so the force on this particle is this way, vertically downwards, lined up with the palm of my hand. As the particle bends because it's being pulled in that direction, so it starts moving this way, what you can see is that the slapping keeps being at 90 degrees and will move this negative particle into a circle.